Today I am going to discuss how to optimize any transportation problem. In my previous video, I have already discussed to find out the basic feasible solution. That is the first step for solving any transportation problem. I am taking the basic feasible solution done by Vogel's approximation method. My starting point today is the basic feasible solution done by Vogel's approximation method. Now I'm going to show the MODI method for optimization of that basic feasible solution. This is the transportation problem, and these are the basic feasible solutions: 15, 20, 30, 25, 6 and 4. It is better to just look the problem from my previous video. In that problem, it was given that the total availability and also the total requirements. That means these are the factories A, B, C, D, and these are the warehouses D, E, F, G. Now I am going to show how you will optimize this by MODI method. MODI full form is Modified Distribution Method. These are the cost for transportation: 10, 8, 9, 5, 2, 3, 6, 7, 4, 7, 6, 8. These are the transportation cost. I have already explained. This cost means if you shift one unit from factory 1 to warehouse or destination or sales point F, then per unit transportation cost is ₹2. In this way, 4 means the transportation cost for shifting one unit from factory C to destination G. In this way, transportation costs are given. And after applying Vogel's approximation method, the basic feasible solution is 15. That means you have to shift from factory A to destination G or warehouse G 15 units, and from factory B 20 units are being shifted to warehouse F. In this way. In this way, 6 means from factory D the 6 units are being shifted to warehouse F. In this way, the basic allocations are shown in this box. How will start? How will solve this transportation problem by MODI method? Now I am going to discuss MODI method. First of all, before applying MODI, you must have to check the total number of allocations must be equal to m plus n minus 1. The number of allocations must be m plus n minus 1. M means what? M is equal to number of rows, and n means number of columns. You must check before applying MODI method. In this case, m means what? Number of rows 1, 2, 3, 4. Number of rows is 4, and number of columns n means 1, 2, 3. 3 columns are there. That means minimum how much allocations are required? M plus n minus 1. That is 4 plus 3 minus 1. That is 6 number of allocations are required. What are the allocations? These are the allocations. The basic allocations are called allocations. How many allocations in this case? 1, 2, 3, 4, 5, 6. That means we can proceed. Our requirement of minimum allocation is 6, and here it is existing. It exists, and for that reason we can proceed to the next step or next process. If the number of allocations is 5, 4 like that, in that case it will be a case of degeneracy, and that is a special case. How you will solve in the case of degeneracy, that I will discuss later on. First of all, I am taking the straightforward problem. That means in this case we can proceed. Now how you will proceed? What you will do first, you have to divide all the transportation costs for the basic allocations into 2 components. Basic allocation means these are the basic allocation cells, basic cells. The cost of that cell, that is 9, is to be divided in 2 parts, 2 variables. That is called dual variables. In this way, say this cost is to be divided into 2 variables. So suppose the variables are noted by UI and VJ. UI for the rows, that is factories, and VJ for the destinations. So in this case, we are dividing u1, u2, u3, u4. These are the variables because 4 rows are existing in this case. And for column Vj means v1, v2, v3. And with the help of these variables, you have to form the equations. That means you have to divide the transportation cost of the basic cells into two variables. That is dual variables. And here I have noted the equations, how it is. Say u1 plus first one. This is the basic cell because the basic allocation is here. That means if I want to note through equation, this variable is u1 and this variable is v3. v1, v2, v3. That means u1 plus v3 is equal to 9. u1 plus v3 is equal to 9. Next basic cell is this. The cost is this 2. The 2 is equal to 2 is equal to what are the variables? Variables is u2 plus v2. That's why I have written u2 plus v2 is equal to 2 in this. Third basic cell is this. That is u3 plus v3 is equal to 4. This cost is to be bifurcated into two components, u3 and v3. You see u3 plus v3 is equal to 4. Third equation. And this is also basic cell because basic allocations are here. That's why 7. This is equal to v1 plus v4. If we add this, then you will get this. So v1 plus v4, we check v1 plus v4 is equal to 7. This is also basic cell. 6 is equal to v4 plus v2. v4 plus is equal to 6. And last one, this is 8 is equal to v4 plus v3. In this way, as there are 6 allocations, we will get 6 equations in this way. And you have to find out the value of the variables. See, here 6 equations are available, but the variables are 7 because this is 4 and this is 3. 7 variables are available, but the equations through which you have to solve is 6. That means one of the variables you must have to put 0 because you cannot find out the unique value without putting any value to 0. If the number of variables are 6 and the equations are also 6, then there is no issue, no problems. But as the number of variables are higher than the available number of equations, you must have to put one variable 0 arbitrarily, and then you can find out the other variables. So you can select any variable as 0 and then proceed to find out the other variables. Say in this case we are putting the variable u4 is equal to 0, and from equation 6, see this 6, if u4 is equal to 0, then v3 is equal to 8. From equation 1 you can find out u1 is equal to 9 minus 8. From 1, 9 minus v3 is 8. That's why u1 is equal to 1. From equation 4, v1 is equal to, from equation 4, v1 is equal to 7 minus u4, that is 7. In this way you can find out all the values of variables, and that means in this case u1 is equal to plus 1. You see why is the u1? u1 is a plus 1. Then u2 is equal to minus 4, u2 is equal to minus 4, u3 is equal to minus 4. In this way all the v1 is equal to 7, you check v1 is equal to 7, and v2 is equal to 6, and v3 is equal to 8. Where is v3? v3 is equal to 8. You put the values of the variables in this way. u1 is equal to plus 1, u2 is equal to minus 4, u3 is equal to minus 4. Actually the concept behind is this, that the transportation cost for all the basic variables is to be divided into dual variables, two variables. Now row wise the variables are written as ui, and for verticals or columns the variables are noted by vj, and then find out the value of the variables. Now with the help of these variables you have to find out the values of non-basic cell. Where basic allocations are not available, that cells are called non-basic cells. This is non-basic cell, non-basic cell, this is non-basic cell, in this way. Clear? Now with the help of all these variables you have to find out the value of ui plus vj, ui plus vj for all the non-basic cells. And this means row 1 column 2. This means this circle indicates you have to find out u1 plus v2. u1 plus v2, u1 is 1 and v2 is 6, that means plus is 7. I am not discussing all the circles, but I am showing few ones. Suppose this is, I will explain how you will put these values ui plus vj. This is row 3, that is u3 plus v1, u3 plus v1, u3 is minus 4, u3 plus v1, u3 is minus 4 and v1 is 7, that is plus 3. That's why 7 is written. That means in all circles you note the value of uy plus vj. Okay, circles are written on the non-basic cells. Now finally you have to find out the net evaluations. Net evaluations are noted in triangle. What is net evaluations? Which is the indicator for optimization of the transportation problem or not. The indicator is, or z value is noted in the triangle. Z is equal to Cij. Cij is the cost of the transportation. C11 means this transportation cost of this cell. C12 means this. In this way, Cij minus Uy plus Vj. This is called net evaluation. Z is equal to net evaluations. Net evaluations which is calculated by Cij minus Uy plus Vj. If this is greater than is equal to 0 for all the non-basic cells, then we'll consider the transportation problem has been solved. That means we have reached to the optimum. Now we have to calculate the value of the triangles one by one. I am showing how this has been calculated. Cij is this. Cij this is C1, C2, Cij minus Uy plus Vj. Uy Vj is noted here, and this value is Cij minus this 8 minus 7, that is plus 30 in this way. Then how it will be calculated? These are also non-basic cells, and these triangles are noted for non-basic cells only. We will check for non-basic cells only, as we have to check whether there is any better solution or not, because we have to minimize the total cost. This one is Cij. Cij is 10 minus this 8. This is 2. 5 minus 3 is equal to 2. 6 Ui plus Vj is this. I have already noted. 6 minus 3 is 3. 7 minus 2 is 5. Okay. But in this case, you see this is negative. This is Ui plus Vj is 3. Ui plus Vj can check. Ui, that is row 2, u2 plus v3, that is 8 minus 4 is equal to 4. This is Ui plus Vj. Cij, but 3 minus 4 is minus 1. In this case, it is not positive or 0. All triangles values I have calculated here are either 0 or positive. No value is 0 in this case, but it may be 0 also. But in one triangle, the net evaluation value, that is z is equal to Cij, is negative. It indicates that this allocation is not best or optimum. We have to proceed further. Okay. Achha. One thing, I have shown you the detailed process for finding the variables, but if you practice it, then it can be done very easily. That process also I am showing you here. Next time I will not calculate in detail all the equation, and this shortcut process I will follow to save the time. In examination also, a transportation problem may be optimized by 3-4 tables. In that case, if you are interested to solve in detail, then it will take a lot of time. That's why the shortcut method also I will discuss. Here I am showing, because next time I will erase it and will do directly. These values can be find out directly also. What you will do first, okay, that will I will discuss slightly after that. If it is negative, then what you will do? That means if you put some value here, that means if your solution is in this cell, then your cost will be reduced. Here is a scope of cost reduction. Then how much unit you can shift here? That's why I don't know. I just assume theta is a variable. Theta, x, p, whatever you know. You put any variable, you have to shift some quantities from the factory B to destination or warehouse G, by which you can reduce the transportation cost. So how will find out how much you will shift? For that, you put one arbitrary any variable. You have to find out that variable. If you put this variable, then what will happen? This, to make it balance, that means total row value, if you add and subtract, then it can be balanced. If you add theta, then definitely this side the total requirement will be increased by theta. To make it balanced, I minus theta, and again you put minus theta and you put plus theta. Now you can check if you add this side, sorry, theta minus theta, plus theta, and this will be minus theta. You always try to find out square, and by the corner of the square you can adjust the variable. I have added theta here. As it is added, that's why I have subtracted. Again added, again subtracted. If you add, no effect, because theta and minus theta 0. That means the availability will not change. If you add this side, theta minus theta, again it will be no effect, 0. And theta minus theta, again if you add, the total availability remains same. And if you add theta minus theta, then again it will be balanced. Okay, up to this, then again I will discuss. Start. Theta, to add one variable theta, that is, you have to place in such a way so that the total available for the factories and the requirements should not be disturbed. It is better if you could find a square. In this case, this is the square, and I have adjusted with the corners. Here I have put the new variable theta, and this is minus theta. If you total it, there is no effect for the total. For that minus theta and plus theta, there is also remains same. And if you add theta minus theta, no effect, and this is also no effect. Now, what will be the value of theta? The value of theta, you check this difference and this difference, and the lowest difference one you will consider and put it as 0 is equal to 0. That is, theta is equal to 4. If you put theta is equal to 4, then all the values will be either positive or 0, but a new variable will be inserted, included to this cell, and this variable will be dropped. Now how I will proceed, that I am going to show. For that, I am erasing this part. You check it again. I am not repeating. For detailed calculation, I have done all this first time, but in the next case, I will not show these equations in detail, but this is done, which can be easily done directly to this table. That I will show you later on. Now, I need some space. That's why I am erasing on this part. Okay, this part I am erasing. Then what will be the new allocations after inserting theta? That I am going to show you. What allocation will be? Now, I am writing here 4 rows and 3 columns. 1, 2, 3 and 4. 1, 2 and 3. Was 10, 8, 9, 10, 8, 9. 5, 2, 3. 5, 2 and 3. 6, 7, 4. 6, 7, then 4. 7, 6, 8. 7, 6 and 8. What will be the new basic allocation? The value of theta I have taken 4. That's why the new value is being placed at 4. And 4 will be subtracted from here. In place of 20, it will be 16. Theta value is 4. That's why it will be 16. And this is 10. 6 plus 4 is 10. And this is 0. 4 minus 7 is 4 minus 4 is equal to 0. That means this variable is being dropped. This value has been dropped, and this is included. This is 30. This is 30, and no change. And this is also no change. This is the revised matrix. Probably I have written all. No, I have left this 25. Should also write this. So this is the new basic allocation table. After modifying the matrix in this way, we have incorporated a new variable here, new value here, and accordingly adjusted. So again, we have to proceed in the same way as I have already discussed, just in my previous table. In this case, I will solve in the shortcut way directly. If you want to calculate it in detail, you can do it by putting equations. But here I am showing you at the same time how you will find out directly from the matrix. you assume 0. That is the value is, this is V1, V2, V3 and U1, U2 and U3, U4. But I can find out the values directly. How? Suppose I am putting 0 value against this V3. If it is 0, if you add this, then you will get this. That's why it will be 4, it will be 3 and it will be 9. That means 0 for this is the basic cell. You will get this value by adding these two variables U3 plus V3. That means the transportation cost for the basic cells are divided into two variables, and this is the shortcut way by which you can find out the value of the variables directly, easy way that I am going to show you. If you want to calculate in detail, you can do it, no problem. Next, you have to find out this value, and also only this is completed, this value also. I will find out with the help of the basic cells. You have to find out it. 0 you have done 4, 3 you have already calculated, this is 3. That means this will be equal to how much? 2 minus 3 minus 1. If you add this plus this, then you will get this. That's the basic cell value. Okay, in this way. Now you have to find out this value and this value also. I will get this value. This is 0 and this is 8. That means this value will be 8. 8 plus 0 is, sorry, this is not the basic cell. This is with the help of the basic cell you have to find out. This is the basic cell, and 6 is here. 6 minus of minus 1. That means 7. This you put 7 here. Then 7 plus minus 1 is 6. In this way you can find out this value also. You also have to find out this value, how much it will be. This plus this is equal to 7. Then how much it will be? 7 minus 7 is 0. The indirect way is to subtract from this value the available value. Then you will get the other value. That means if you add 0 with 7, you will get 7. In this way, you can find out all the variables. You need not to form the equations separately and to solve it. If you like to do it, you can do it. Then in that case, how will do it? All the basic cell you will write in the equation that I am again showing in this case, but later on I will not show you. This is the basic cell U1 plus V3. U1 plus V3 is equal to 9. This is basic cell. That means U2 plus V2. U2 plus V2. U2 plus V2 is equal to 2. This is the equation. Then this is U2 plus V3. This is V3. U2 plus V3 is equal to 4. This is. Now U3 plus V3. U3 plus V3 is equal to 4. U3 plus V3 is equal to 4. Well, I have mistake something here. U2 plus V2. No, I have written wrong. First U1 plus V3 is equal to 9. Okay. Then second is U2 plus V2 is equal to 2. That is also okay. U2 plus V3. U2 plus V3 is 3, not 4. U2 plus V3 is 3. And U3 plus V3 is equal to 4. Okay. And this is V1 plus U3. This is V1 plus U4. V1 plus U4 is equal to 7. And last is V2 plus U4. V2 plus U4 is equal to 6. How many equations? 1, 2, 3, 4, 5, 6. And variable is 7. So you can solve by putting one variable as 0. So here I have already shown. I have assumed let V3 is equal to 0. If V3 is equal to 0, then what is the value of U1? Then U1 will be 9. If you put in this equation, if V3 is equal to 0, then U1 is equal to 9 in this way. Next, V3 said this. Then what is the value of U2? U2 will be, U2 is equal to, V3 is equal to 0. That way U2 is equal to 3. You check. U1 is equal to 9. U1 is equal to 9. U2 is equal to 3. U2 is equal to 3. In this way, if you try, then you can check it. The value, all the values are this. So it is the direct and shortcut method by which you can find out all the dual values variables. Okay. Now my next step is to find out the value of circles, the value of the circles, that means Ui plus Vj for all the non-basic cells. These are the non-basic cells. This is also non-basic cells. This is also non-basic cells. This means it is Ui plus Vj. Ui by Vj, in this case Ui, that is equal to U1 plus V2. What is U1? U1 is 0, and this is V2 plus U1 plus V2. Sorry, U1 plus V2. That is 9 minus 1. This is 8. This is 8. And in this case, you can check 0 plus 9. This is 9. Next, 0 plus 3. This is equal to 3. And this is 0 plus 4. That's why this is equal to 4. Minus 1 plus 4. This is 3. Minus 1 plus 4. This is 0 plus 7. That's why 7. This is I am explaining how this means Ui plus Vj. Ui means Ui 1, 2, 3, 4. That is U4 plus Vj means V3. What is the value of U4? The value of U4 is U4. See, this is U4. U4 is 7 plus V3 is 0. 7 plus 0 is 7. So you can put it directly, not shortcut way to make the process fast. But was you should do in detail. Now, finally, you have to find out the value of triangle. Triangle means this triangle for the non-basic cell or the non-basic cells, and the value of the triangles must be positive. The value of the triangles must be positive or 0 for optimum values. For optimum values. Okay. Now, what is the value of triangle? Triangle means Cij minus Ui plus Vj. This is, and this must be greater than or equal to 0 for optimum. This is the condition for optimum. Okay, and actually this is circle and this is the triangle. So in this case, how much? 10 minus 9. This is plus 1. 8 minus 8. 0. 5 minus 3 plus 2, and for this 7 minus 3, this is plus 4, and 6 by plus 2, and 8 minus 5 plus 1. All triangle values are greater than 1. That's why we have reached to the optimum. This is the best allocation. You cannot reduce the transportation cost by changing any allocations, and the cost in this case will be minimum. You can test also. Then what is the best transportation cost? You can find out it. The transportation cost will be, this is the basic allocation, 15 into 9 plus 15 into 9 plus 16 into 2, 16 into 2 plus 4 into 3, 4 into 3 plus 30 into 4, 30 into 4 plus 25 into 7, 25 into 7 plus 10 into 6 plus 10 into 6. The total cost will be, you can write, that is, what will be the total cost? The total cost will be 538. 538. Sorry. Have to calculate 15 into 9 plus 32 plus 12 plus 120 plus 25 into 7 plus 16, and total is 534. 534. 534. This is the minimum transportation cost. But in this case, the previous level, as per this allocation, the total cost was 538. That means after changing the allocations, this is the advantage. They have reduced cost by rupees 4. And as all the net allocations that means net evaluation value Cij minus Ui plus Vj greater than is equal to 0. That means the optimum has been reached. In this way, you can find out the optimum allocation for any transportation problem in two steps. In first step, to find out the basic allocation which is not optimum, and by second step using Modi method you can find out the optimum allocation. Then what would be the decision for transportation? You have to shift A, B, C, D and E, F, G. You have to shift from factory A to warehouse or selling point G 15 units, and you have to shift from factory B to warehouse F 60 units, and from factory B to go down or selling point G, warehouse G 4 units, from factory C to warehouse G 30 units, from factory D to factory warehouse E 25 units, and from factory D to warehouse F 10 units, and the total minimum cost will be 534. This is the optimum solution. If you try by changing any allocation out of this, from this, if you deviate to any other allocation, then you will see the cost will be increased. That is the advantage for Modi method. Thank you. If you have any question, that you can give to the comments box, and I am always ready to reply for that. Again, I am repeating, in the first step of Modi method, I have shown the detailed calculation through forming equations. But in the second step, I have done it directly. Always in your exam, first one, once you will show in detail, then you can done indirectly. Later on, in my different video, I will show the exceptional cases. What are the exceptional cases? For that I have not discussed here. The exceptional cases are, sometimes you will see that the transportation problem will be unbalanced, which is checked at the starting point for solving. That means the total of the availability and the total of the requirements are not same. That are how we will solve it. That I will discuss in my separate video. Only minor modifications are required. First, you have to make it balanced problem. The same way you have to proceed to solve it for optimization. And another, you sometimes may find that variables allocation, basic allocations are dropped. That is, may not be equal to or more than m plus n minus 1. If it is less than m plus n minus 1, then it is called a degeneracy problem. In that case, how we will solve that also I will discuss later on. And this is a flat minimization problem. As transportation cost is given, sometimes you will see instead of cost, profit will be given. Means suppose if you are producing in this factory and selling this outlet sales point, the profit per unit is this. In this way, not cost, the profit will be given. Suppose you are producing in this factory and sales, you are shifting the product to G, then the profit per unit is given as 3. This way, instead of cost values, the profit per unit is given. That means in that case, the problem will be maximization problem in the case of transportation. Then how we solve it, that also I will discuss in my separate video. So I think I try my best to cover all the types of problems so that you should not face any problem. So here again I am repeating, for applying in every matrix for modification, you always check first m plus n minus 1 basic allocations are available. If it is not, then you should understand it is a case of degeneracy. You have to modify it. You have to modify it. Here again it is available because 1, 2, 3, 4, 5, 6. 1, 2, 3, 1 basic allocation 1, 2, 3, 4, 5, 6. M plus n minus 1 is 6. 6 basic allocations are available. That's why I could solve it. If it is not, say 5, sometimes it may be dropped in between process also, then you have to, some modification is required. That is called degeneracy problem. Okay, thank you. I think we will be benefited by this, and you also follow my other videos where I will deal the special problems of transportation. Thank you.